Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 5-4 Part 1 homework solutions on solving radical equations. To start this problem off, we're going to try to isolate this radical term. So first thing I'll do is subtract 13 from both sides. That'll give me negative 24 over there. And then let me divide by negative 2 to get this radical by itself. So we have radical 24x equals 12. To get rid of the radical, we're going to raise both sides to the index. Since this is a square root, we're going to square both sides. That leaves us with 24x equals whatever 12 squared is. I believe that's 144. And then dividing both sides by 24, we end up with x equals 6. Now we just have to check and make sure that actually works. So plugging this back into the original, we have square root of 24 times 6, so that's the square root of 144. And then the square root of 144 is 12. Negative 2 times 12 gives us negative 24. And negative 24 plus 13 gives us negative 11. So that works out, and 6 is actually the answer. For this problem, since we have one radical on each side, we can immediately raise both sides to the index, which is the second power. So squaring both sides, basically getting rid of the square roots, we just end up with 4x plus 1 equals x plus 10. And then I can subtract x over to the left, giving me a 3x over there. Subtracting 1 over to the right gives me a 9. And dividing by 3 gives me 3 for my answer. But let's plug it in and make sure it actually works. So we have 4 times 3 plus 1, square root of that. And also 3 plus 10, square root of that. This is going to be the square root of 13 on the left and the square root of 13 on the right. Since those are the same thing, that means that 3 is our answer. To tackle this problem with these two cube roots, we're going to get exactly one cube root on each side of the equation. So I'm just going to add this cube root of 8x plus 1 over to the right side. And now, once I've done that, I can cube both sides of this to get rid of the cube root. So that's going to be 2x minus 5 equals 8x plus 1. And now let me move the x's over to the left. I guess it doesn't really matter, but 2x minus 8x, that'll be a negative 6x over there. Let me move 5 over to the right. Adding 5 over there gives me a 6. Dividing by negative 6 gives me x equals negative 1. Now let me plug this back into the original. So I've got cube root of 2 times negative 1 minus 5. Minus cube root of 8 times negative 1 plus 1. So we have negative 2 minus 5. That's going to be negative 7 in that cube root. Over here, this is negative 8 plus 1, which is also negative 7 inside the cube root. If I take the cube root of negative 7, whatever that is, and subtract it from itself, that's going to end up being 0. So we do end up with 0 equals 0, which confirms that negative 1 is our answer. For this problem, we've already got the radical expression isolated, so we can go straight to using an exponent on both sides. Since this is a square root, we're going to square both sides. So I'll have just plain old 3x on the right side, and I'll have x minus 6 quantity squared on the left side. Let me expand out that left side so I can move things together at some point. So we're going to have x squared, and then multiply these together and double it for the middle term. So that's going to be negative 12x. And then finally plus 36 equals 3x. And then just one little extra step. Let's subtract this 3x over to the left side to get 0 on one side. So negative 12x minus 3x is going to give us negative 15x over there. Now we have a quadratic, and it's 1x squared. A equals 1 there. So I think I should at least try factoring this first. Are there things that multiply to 36 and add up to negative 15? Well, let me think. 1 and 36, no. 2 and 18 doesn't work. 3 and 12. Well, negative 3 and negative 12 adds up to negative 15. So we have x minus 3 and x minus 12 equals 0. Zeroing each of these out, we're going to end up with x equals 3 and 12. Or does it? We need to check these to make sure they actually make the original equation true. We might have some extraneous roots here. So let's plug 3 in first. I've got 3 minus 6 and the square root of 3 times 3. And I'm asking, are these two things equivalent? So on the left side, I've got negative 3. On the right side, this is the square root of 9. The square root of 9 is positive 3, which does not equal negative 3. That means that this answer of 3 over here is extraneous and we have to eliminate that. Hopefully 12 works. Let's plug that one in now. So we've got 12 minus 6 equaling radical 3 times 12. Again, or does it? We need to find out. So this is going to be 6 on the left, radical 36 on the right. The square root of 36 is indeed 6. That works. So 12 is a good answer. For this problem, we're trying to solve this cubic root equation. Because the radical is already isolated on one side, we can go straight to raising both sides to the index of 3. So if I raise the left side to the third power, that just gives me 2x cubed minus 1. On the right side, we have x cubed. And since I've only got cubes and constants, I think I can solve this by just moving the cubes on one side and the 1 on the other side. So if I subtract x cubed from both sides, I have 1x cubed on the left. And then if I add 1 over to the right side, well, we've got 1. And then I just have to take the cube root of both sides. The cube root of 1 is just 1. So you might be thinking, well, if we have x cubed minus 1, isn't it also possible to factor this into, I think it would be what, x minus 1 and x squared plus x plus 1? But that other factor wouldn't give us any real solutions. So we're just going to stick with 1 as our answer here. So now let's plug that back in and see if it works. So I have 2 times 1 cubed minus 1. That's just 2 times 1, which is 2, minus 1 is going to be 1. So we have the cube root of 1 on the left, just plain old 1 on the right. And the cube root of 1 is 1, so this works out. 1 is a good answer.